This is an RNZ podcast. Kia ora and a warm welcome to Elemental, a podcast from RNZ. I'm Alison Balance. I'm a latecomer to the joys of chemistry, but I'm learning fast.
And I'm Professor Allan Blackman from the Auckland University of Technology, and I am relearning things that I once knew but probably have forgotten in the intervening years, and I'm thoroughly enjoying this trip through the elements.
It's the beginning of April, and we've just made it to the end of the B's on the periodic table, which brings us to bromine. And am I right, and am I managing to make some sense of chemistry, or at least the naming conventions for chemistry? Do I take it that since it doesn't end in IUM, it isn't a metal?
You are correct in saying that, but not all metals end in IUM. You got me looking on the periodic table for that, and, you know, things like zinc, copper, gold.
Oh,
tungsten, tantalum.
Oh,
just,
no.
Just to name a few.
It's like all of those rules that turn out to not be rules. Anyway, tell me about bromine.
Okay, well, you're right in the fact that it isn't a metal, and it is what we call a non-metal, which does seem fairly sort of self-explanatory. If it's not a metal, it's a non-metal, unless it's a metalloid.
It's such a letdown being to find what you're not.
Yeah, no, you're absolutely right there. Yes, I would totally agree, but, you know, that's what we've got. We've got to stick with that. So it is a non-metal, it's vital statistics, okay, it's element number 35, and that puts it sort of into the middle right-hand side of the periodic table. It was discovered in 1826, and its name comes from the Greek bromos, which means stench, and certainly if you've ever smelled bromine, you will know that it is very, very aptly named. And bromine is the second element that we've come across that's in group 17.
Who's the other one?
The other one was astatine.
Yes, astatine. I can
barely remember it.
It was back in the A's, everybody.
It was. And both astatine and bromine, and indeed all the elements in group 17, are known as halogens. And again, if you remember the astatine episode, that means that they form salts. And it also means that all of these elements have got 7 electrons in their outer shell of electrons, and 7 is not the number that they want. They really, really, really want 8, and that means that they sort of react all very similarly. Now, the big news about bromine, the very, very unusual thing about bromine is that at room temperature and pressure, it is one of only 2 elements that are liquid.
I'd never thought about that. But you're right, so lots of solids and lots of gases, but only 2 elemental liquids.
Yeah.
So why is it a liquid, and why is that so unusual for an element?
Well, I'm going to be very, very hand-wavy here. If you've got a solid, that means your forces between the atoms, or the molecules indeed, in that solid are very strong. If you've got a gas, the opposite applies. That means that those forces are very weak. If you've got a liquid, those forces are middling.
Is middling a technical term?
Not really.
A hand-wavy term.
It's all to do, as I said, with the forces between your constituent particles. So in liquids, the forces between the constituent particles are large enough for them not to be gases. So you've got some attractive forces there, but those attractive forces aren't strong enough to turn them into a solid.
I'll be looking at my glass of water differently from now on. Even though that's not an elemental liquid, I do get that.
Indeed, and it's not just any old liquid. It's a beautiful, beautiful deep red liquid. And it fumes like crazy, so you get these beautiful red-orange fumes of bromine gas above any sample of bromine liquid.
Oh, that sounds super dramatic. It's like something you'd see in a film. Where would I find it?
Well, one of the places that you do find it in quite large quantities is in the Dead Sea and surrounds. And bromine, or should we call it bromide, which we'll talk about in a minute, is the reason that the Dead Sea is so buoyant and why you float in there.
So bromine, bromide, you better explain that to me.
Bromine is highly poisonous, toxic stuff, and it's a molecule, and its formula is Br2, whereas bromide is what happens when bromine gains an electron, and it forms the negatively charged bromide ion, and that's not sort of toxic for you. Big difference between the two things, and when we get to fluorine and fluoride, I'll have a big rant about teeth and that same sort of thing.
The fact that the Dead Sea is bromide is the reason it's not a fuming Red Sea, because I was just trying to imagine that would be really dramatic, but then I feel it ought to be the reason that the Red Sea gets its name, not the Dead Sea. Never mind.
Indeed. And segueing beautifully from red to purple here, there's a story about bromine and the ancient Romans and why they wore purple robes, or why their purple robes were so prized. Purple was a very, very hard colour to get hold of, and in order to do this, you had to basically take one hell of a lot of molluscs and crush them up and extract tiny amounts of this stuff that they called Tyrian purple. That was a dye that came from these molluscs, and that was a compound that contained bromine.
Now, bromide in particular, is ringing bells for me, and I'm sure it's been in the news a lot recently. Remind me what that's about.
Yeah, those of you who have been listening over the past sort of few years will perhaps be familiar with the name methyl bromide, and that is used as a fumigant at ports around the country. Now, there's a little bit of controversy over this. It's used as a fumigant to kill insects.
Can I interrupt? Because as putting my zoologist hat on, Alan, I feel like bromine really has it in for the invertebrate world. First of all, we are mass slaughtering snails to turn togas purple, and now we're killing insects with it. And I'm assuming that the bromide salts in the Dead Sea are also the reason there's no life there.
Spoken like a true zoologist, indeed. But there are potential concerns about this because it can deplete the ozone layer. Often we find molecules that do contain these halogen atoms, such as your bromides and your fluorides and your iodides, etc., don't have a very, very good effect on the atmosphere. And so they're looking at new rules for the use of methyl bromide, and they're, really actively looking for something else that can do the job effectively. And the same thing also applies to the use of bromine in fire retardants. It is used quite a lot. The reason being because it's heavy, one of the reasons anyway, and it makes things more difficult to burn. But again, there are questions over its safety.
Well, thinking of safety, wasn't bromine used in an early attempt at chemical warfare? I'm sure I've read that somewhere.
The very first chemical warfare agent was, in fact, chlorine gas, and that was first used by the Germans. The French apparently then tried to use bromine as a chemical warfare agent, so they tried to gas the Germans in World War I, and obviously when you're using these gases, it all depends on which way the wind's blowing and how strong the wind's blowing. Mm-hmm. And apparently the French were not very successful with this. The wind was blowing in the wrong direction, or it was too much or something, and it all got dispersed, and it was a great big failure. But on the warfare matter, there's an old rumour or a myth or whatever you want to call it about, in the First World War, bromide being put into soldiers' tea in order to lessen their urges, if you get what I'm saying, Alison.
Oh, yes.
But apparently, according to the research I've done, that is indeed a myth.
So bromine sounds pretty nasty all up when it's not being a failure. Does it have anything good going for it?
Well, back in the days of real photography, shall we say, or film photography, I suppose, bromine was widely used in the form of silver bromide, and that was used because it's very, very light sensitive, and that was particularly used in sort of black and white film, and those photographers who still use film would swear by that.
And I'm sure I've seen it in the credits of artistic photographs in art galleries. Deadly but also artistic. So, that was Bromine, episode 11 of Elemental, a podcast from RNZ. You can find all the previous episodes online at rnz.co.nz/chemistry.
And you can also subscribe as a podcast and catch up with all of the past and indeed future episodes at your favourite podcast provider.
And there's going to be a few of those. If you're enjoying Elemental, please rate or review us if you can. And otherwise, word of mouth is the best kind of advertising. So please share us on social media, tell your friends. Thanks heaps. I'm Alison Balance.
And I'm Allan Blackman. See you next time.